Alrighty, so this next question here deals with the sampling distribution of the sample proportion p hat. According to creditcard.com, 29% of adults do not own a credit card. Part A, suppose a random sample of 500 adults is asked, do you own a credit card? Describe the sampling distribution of p hat, the proportion of adults who own a credit card. So this question here, we ask 500 adults, do you own a credit card? And this is just to give us, an idea of what the percentage of Americans who say yes I do and no I do not. So when we ask this question, we're really getting the percentage of adults who do own a credit card, and we're getting the percentage of adults who do not own a credit card. Now, the sampling distribution of the sample proportion is always going to follow a normal distribution. And so we can say something like this, p hat follows a normal distribution with a mean and a standard deviation. Okay. Now, the mean and standard deviation of this distribution is going to be given by these two formulas here, okay? So the mean is just going to be equal to what it is currently, okay? The population proportion P, which is 0.29. And then the standard deviation is 0.29, 1 minus 0.29 divided by the sample size. So we get 500 here. Okay? And this turns out to be 0203. Okay? So now we can say that p hat, we can go back and fill all this information in here. P hat follows a normal distribution with a mean of 0.29 and a standard deviation of 0.023. And remember, this is a random variable just like x. So x is also a random variable, and x bar and x. These are all three random variables. And this is just to point this out here, this is a non-standard normal, okay? Remember, the standard normal has a mean of 0 and a standard deviation of 1. This has a mean other than 0, so a standard deviation other than 1, so this is non-standard. Now, the z-score that we're going to use to convert the non-standard normal, which is here, into the standard normal, this is z-score formula, is right here. P hat minus mu p hat over sigma p hat. So p hat, remember, is x over n. Mu p hat, remember, we're going to get mu p hat from right here. Okay? And sigma p hat is going to be given by this value. Notice, sigma p hat is given by 0203, which is the standard deviation. Okay, so let's move on to the next question here. Okay, so let's go ahead and write this down. I'm going to be very clear about what we're doing here. So I'm going to say p hat follows a normal distribution with mu p hat, the mean of the normal distribution, equal to 0.29, and sigma p hat equal to standard deviation, which we calculated above, 0.0203. And this is what we're going to use. The question is, what is the probability that in a random sample of 500 adults, more than 30% do not own a credit card. So we're going to graph this normal distribution here. This is what we're graphing, p hat, with a mean of 0.29, standard deviation given by here. We want to know what's the probability that in a random sample of 500 adults that more than 30%. So 30% is going to be to the right of 29%. And this is the probability we're looking for. So from the picture here, we should be able to get a formula. What is the probability that our sample proportion, p hat sample from the 500, results in a percentage that is greater than 30%. So what we have to do is we have to convert our boundary point. We have to convert using the z-score, p hat minus mu p hat over sigma p hat. So p hat is 0.3 minus mu p hat is 29 over sigma p hat, 0203. And we get a z-score of 0.49. So what we've done is we've converted this non-standard normal into a standard normal with the mean of 0, and the 0.3 becomes 0.49 z-score. So we get probability that z is greater than 0.49. And then by symmetry we can say this is the same as the area to the left of minus 0.49. And look this up in the table and we get table 5. Remember, we look up table 5 now. Table 5. We look up this z-score of minus 0.49 and we get 3121. Which is also the probability, the area under the curve. Okay, moving on to the next question. What is the probability that in a random sample of 500 adults between 25 and 30% do not own a credit card? Okay, so you want to pay attention to the sample size. If the sample size is the same, then everything is really nice because we can use the same distribution that we used before with the mean of 0.29 and standard deviation of 0.0203. If the sample size changes, then our entire distribution changes. So you want to pay close attention to that. Now, since everything is the same, we can go ahead and use the same exact distribution that we used before, which is p hat follows the normal distribution with a mean 0.29, standard deviation 0203. Now let's draw our picture here, and our distribution has a mean, this is p hat of 29, and we're going to locate our boundary points, okay? And our boundary points are from 25 to 30%. So let's locate 25%, which is going to be over here. And then 30% is going to be to the right. And we want to know between 25 and 30. So this is the area that we're looking for here. Now from the picture we should be able to get our formula. What is the probability that p hat is between 25 and 30%. Okay, so again, we're dealing with p hat, which is non-standard normal. We have to convert that into a standard normal using the z-score p hat minus mu p hat over sigma p hat. And we've got two of these z-score formulas, two of these boundary points we have to convert. So let's go ahead and get the first one here. 0.25 minus 0.29 over sigma p hat 0.0203. So we get a z-score of minus 1.97. Let's convert this one over here. .0203. So the z-score formula gives us a z-score of 0.49. So this becomes 0, this becomes 0.49, and minus 1.97. Which again, remember, this means that 0.25 is 1.97 standard deviations below the mean. So let's go ahead and convert p hat into z. Now we have to find the area in between two values, and we've looked at this several times, but remember, if we look up the z-score of 0.49, we're going to get the area from this point all the way back. And then when we look up the z-score minus 1.97, we get the area from this point all the way back. So if we take the difference between the two, we get what's in the center. Probability of the area to the left of 49. Take out the area where z is less than 1.97. So let's look 0.49 up in table 5, and we get 6879. 0244 when we look up minus 1.97. So that gives us the area under the curve here. .35. Okay, next question. Or last part. Would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? So again, the same distribution as before. We're using the same exact distribution as before. So the mean is exact same, standard deviation is exactly the same. And we're going to locate, now, 125 or fewer. Okay, so what we're saying here is out of the 500 adults that we've selected, what is the probability that 125 or fewer do not own a credit card? So really what we're saying is x is less than or equal to 125. And what this tells us, this really tells us that p hat is going to be less than or equal to 125 over 500, or p hat less than or equal to 0.25. So we've got our boundary point now from here. 0.25 is going to be to the left of 0.29. So saying that less than 125 out of 500 is the exact same statement as saying p hat, the percentage of the 5, is less than 25% or less than 1/4. So this is the probability that we're looking for right here. Again, from the picture, we're going to get our formula. Probability that p hat is less than or equal to 0.25. Now we have to convert our boundary point. And I think we converted the boundary point before, but we'll do it again. Minus mu over sigma p hat. So 0.25 minus 0.29 over standard deviation 0203. Rounding 2 decimal places, we get z-score of minus 1.97. So we've converted p hat axis into a z-axis. This becomes the mean for the standard normal, and the z-score is 1.97. And here we're finding the area to the left, so we just look it up. We don't have to worry about using the complement or the symmetry idea. And so we just look up minus 1.97 and we get 0.0244. Okay, fantastic, fantastic. Okay, next question here. Now, this question here is very similar to the question that we just talked about dealing with the seat belts, because we've got qualitative data, and then we've got the number of responses, sample of 521. So we know the total here. If we total all this up, we get 521. We'll just do it in red. 521. As that's our sample, right? 521 is our sample. So, dining out poll. How often do you dine out? Okay. Never. 5 out of 521. Very rarely. A few times a month. Once or twice a week. Several times a week. I usually stick to maybe once a week. I try to stick to once a week just because it's so expensive. Okay, so construct a relative frequency distribution. Now, again, this is very easy to do. Each category, and I've got this already in here for us just to save a little bit of time. But what I did is I just took each one, 103, and divided it by 521. And rounded to 2 decimal places, you get 20% here. Okay, so I did that for each category, and you can see down here is my total 521. Okay, so this is the relative frequency distribution. This is the relative frequency distribution. It just gives you the percentages for each response. Now, the next question is going to ask us to draw a relative frequency bar graph. So you don't want to mix up bar graph and histogram. Sometimes if I am thinking a little bit fast or unclear, then I seem to mix those two up. Okay. All right, so let's go to the next page, and here we want to know, well, we're going to construct a relative frequency bar graph here, but and I've done that. Again, you just draw the height of the bar to the frequency here. Okay, and then part B says, what proportion of those surveyed dine out once or twice a week? Well, it's really easy once you get this nice picture. once or twice a week is 39%. Okay, so you can say something like probability once or twice a week is equal to 39%. Okay, the last question for the final review is dealing with the distribution of sample proportions, and we've had one like this. We just worked one like this a couple problems back. And so let's go ahead and read through here. Frank Newport, Gallup editor-in-chief, reveals that 75% in the U.S. say it would be positive for society if more Americans were religious. Okay? And then part A, if a sample of 100 Americans is obtained, what is the probability that at least 70 of the 100 Americans say it would be positive for society if more Americans were religious? Okay, so we're dealing with the distribution of sample proportions here, okay? And if you remember what this looks like, we say that p hat follows a normal distribution, with the mean of the normal equal to p and the standard deviation for the normal distribution equal to the square root of p, 1 minus p over n. Okay? And so p, sort of the standard here, is 75%. So let's go ahead and plug this in. (75) 1 minus 75 over the sample size. Now, here our sample size is 100. So we get normal distribution with a mean of 7.5 and a standard deviation of 0.433. Okay, so this is our picture. This is what we're going to draw. We're going to draw a non-standard normal curve with a mean of 0.75, and then we want to locate our boundary point. So at least 70. Again, x is at least 70 implies p hat is at least 70 over 100, or 70%. So that's our boundary point here. And at least means all of this. So this is the probability that we're looking for. So from the picture, we should be able to get our formula here. Probability p hat is at least 70%. Now we have to convert. Remember, we have to convert our boundary point. So let's go ahead and convert p hat into z. Over sigma p hat. So this gives us 0.7 minus 0.75 over standard deviation 0.433. And we get a z-score of minus 1.15. So now we can convert this into 0. This becomes minus 1.15. And so now we can convert. Z is greater than or equal to minus 1.15. And so remember, we're asking to find the area to the right. So we either have to use the complement, because the table only gives us the area to the left. We have to use the complement or the idea of symmetry, which says that the probability z is greater than or equal to -1 is the same probability as z less than or equal to positive 1.15. Now we can just look up 1.15 in table 5 and we get the probability. (8.749). Okay, so let's take a look at the next part B. If a sample of 250 Americans is obtained, what is the probability that less than 170 of the 250 Americans, say it would be positive for society if more Americans were religious? Now this question here, I'm going to go to a new page here, give us a little bit more room. But one thing that you want to pay attention to initially is that the sample size has changed. We're no longer selecting 100 Americans, but now we're selecting 250 Americans. And this is very important because what happens is the sampling distribution is also going to change. So let's see what the sampling distribution for this random variable p hat based on a sample size of 250 looks like. And essentially everything is going to be very similar. P hat will follow a normal, and the mean p hat is going to be equal to p, and sigma p hat will be the exact same thing, the square root of p 1 minus p over n. So all of this is going to be the same. Sigma p hat, however, is going to be different. It's going to be the same, 0.751 minus, all the way up until this point. N is what's changing. So N, instead of 100, it's going to be 250 this time. Okay? And that's the only difference. So mu p hat is equal to p, the population proportion. And let's go ahead and get a decimal for this because we're going to have to use it here in just a second. So I got something like 0.0274 for this. Okay, and this is a non-standard random variable, follows a normal distribution with the mean of this, standard deviation of this. Now, let's go back and see what the question is asking now that we've described the distribution. What's the probability that less than 170 of the 250, so x less than 170 is the same thing that's saying p hat is less than 170 over 250, or p hat less than 68%. So now we can go ahead and draw our standard normal bell curve, label with the mean of 7.5, and we're going to find our boundary point 6.8 p hat, and then we're going to convert. Remember, we're going to convert our boundary point. That's the probability we're looking for. Our boundary point of 6.8 into a z-score using the z-score formula. So p hat minus mu p hat over sigma p hat. 0.68 minus 0.75 over the new standard deviation. This is the new standard deviation, 0.274. So the z-score we get is minus 2.55. So this goes to 0. This p hat becomes a z-score of minus 2.55. Now we can convert. So let's say probability p hat is less than 0.68. That's from our picture here. And we're going to convert p hat into z, minus 2.55. And so now all we have to do is look up minus 2.55 from table 5 and get the probability. Okay, so when I look up minus 2.55, I get 0.0054. So the probability here is also 0.0054 is also the area under the curve. Okay, so I believe this just about wraps up all of the different problems. I think we have one more problem here. Okay, part C, this is the very last question. And again, you want to pay close attention to the sample size. If you select 100 individuals, what is the probability that between 70 and 80 say it would be positive for society if more Americans were religious? So the first thing, again, you want to do is describe the distribution of p hat. Okay, so mu p hat is equal to 75. That's what it was before. Haven't changed that. Just part C is a different. Now this is going to be exactly the same as it was for part A. So we've got a standard deviation of 0.0433. So nothing has changed. Only part B. Part B changed because we changed the sample size from 100 to 250. So the standard deviation had to change. So this, we're going back to the sample size of 100 so we can use the exact same distribution. So now let's figure out what we're going to say here for p hat. Now between 70 and 80, what we have to do is we have to calculate those two percentages. Okay, so what we're really saying here is between 70 and 80. So we're saying that x has to be between 70 and 80. Now that's the same thing as saying that p hat has to be less than 80 over the sample size or greater than 70%. So we get 0.7, p hat 0.8. So again, saying that x is between 70 and 80 is the same thing as saying that p hat, the sample percentage, the sample proportion, is between 70 and 80%, right? Because our sample is 100. So let's label the mean of the normal distribution, non-standard normal, as 75. And then we'll label our boundary points. So 0.7 and 0.8. Okay, and the probability in between there is what we're really looking for. So we say, what is the probability that p hat is greater than 70% but less than 80%? So you know what's coming next. We have to convert p hat into z-score. So z is equal to p hat, which is lower bound is 0.7 minus 0.75 over the new standard deviation, 0.0433. So here we get minus 1.15, and then 0.8 is equal distance, so you know it's going to be positive 1.15, but we'll go ahead and calculate it again. 0.8 minus 0.75 over standard deviation, sigma p hat, 0.433. We get z is equal to 1.15. So this becomes 0, this becomes minus 1.15, and then 0.8 is converted to 1.15. So now we can write our formula in terms of z. (1.15), and now we use the idea that we've talked about before. This is equal to the probability where z is less than positive 1.15 minus the probability where z is less than minus 1.15. So now we just have to look up from table 5 and when I look up 1.15 I get 0.8749, and then when I look up minus 1.15 I get 0.1251, which gives us a probability of 7498. Okay, so that concludes the sample review videos that I told you that I was going to do. And so if you believe that the videos have helped you, then what I'd like for you to do is just go and comment below about how you feel the videos have helped. Okay? And so I'll see you guys next week sometime to review for the final.